Good morning, everyone. Today we're going to be reviewing for the test that we'll have tomorrow on Wednesday, which is on the modeling linear functions unit. So what you're expected to do today is to watch this video. And as you are watching, you should be completing the examples on your own copy of this Jamboard that is in your Google Classroom. Once you hand in this assignment completed, if it's completed, you'll have a 100 as a classwork grade. So again, all you have to do is watch this and copy down as we go along and review for your test tomorrow. So let's get started. Write the slope-intercept form of the equation of the line given the slope and the y-intercept. So remember, slope-intercept form is y equals mx plus b. Remember, m is your slope and b is your y-intercept. So if we're given a slope of -3/4 and a y-intercept of -4, we simply have to plug it in to y equals mx plus b, so y will stay the same. M is the slope, we'll change to -3/4. We multiply that by x, and then we have plus b, but when we have a negative y-intercept, then it will be minus b, so we have -4. So slope-intercept form would be y equals -3/4 x minus 4. Next, we want to find the slope of the line through the pair of points. So remember, the slope formula is y2 minus y1 over x2 minus x1. And we can label the points that were given. So we have x1, y1 in our first point, x2, y2 in our second point. So from here, all we have to do is fill in the numbers in the correct spot in our formula. So we have y2, which is -15, minus y1, which is -16, over x2, which is -7, minus x1, which is 19. So we have -15 minus -16 really changes it to plus, but just plug it right into your calculator and you'll see it's a 1. And then we have -7 minus 19, which gives me -26. So the slope is 1 over -26, or you can also write -1 over 26. Those would both be considered right. Next, we have function g of x is showing in the graph at the right. Find the average rate of change over the interval when x is from 1 to 4. So the average rate of change is our slope again. So let me just zoom in a little bit. We really have y2 minus y1 over x2 minus x1. So how we find the average rate of change is when we have our x to be 1, we want to know what our y value is. Same thing when our x is 4, what is our y value? Well, we can either plug it into our formula, which we have g of x is the square root of x. So what we could do is when we have g of 1, find the square root of 1, which gives me 1, so the 0.11. And then we have g of 4, which gives me the square root of 4, which is 2. So I have the 0.42, and you can also see that on the graph here. So the 0.11 and 42, that we want to find the rate of change between when x is 1 and 4. So again, it's just the slope here. So we're going to plug in using our points to our slope formula. So x1, y1, x2, y2. So that means we have 2 minus 1 over 4 minus 1, which gives me 1 over 3. So the average rate of change is 1/3 here between the intervals 1 and 4. Next, we're going to graph the following line. We have -6x plus 3. So we can use a graphing calculator and we can plug it right in here. So it's negative 6x plus 3. Here's our line, but it's very important that we choose numbers from our table so that we can graph it correctly. So we don't have to choose a lot of numbers. Maybe I'll start from -1 because I don't think our graph goes up to 15 anyway. So -1, 9, 0, 3. So here we have x and y. So we have -1, 9, 0, 3, 1, -3, and 2, -9. Okay, so we want to make sure we copy some of the table over before we actually graph it. So we're going to graph the point -1, 9, and it only goes up to 6 here. So we're not going to graph that one. We're going to start with 0, 3. So 0, 3 is right here. And 1, -3 is here. And then again, the -9 is a little too far. But we can draw our line here. Okay, and I extend it up this way. Oops. Okay, we want to draw the arrows at the end. Okay, this was a little crooked here, but you get the idea. We should have at least a couple points on the graph in order to draw it, but use that Desmos calculator here, okay? Okay, next we are going to find the x and y intercepts and then graph the line. So we have 4x plus 5y equals 20. So if you remember, to find the x-intercept, you're going to plug in a 0 for y. So we want to find x, and our 0 is going to be y. So when we have 4x plus 5y, we're going to say 4, oops, I'm sorry. No, this was right. 4x plus 5 times 0 equals 20. 5 times 0 is just 0, so we have 4x equals 20. And then we can solve for x, and we get x equals 5. So that means our x-intercept is the point 5, 0. So when you graph it, it should be on the line. On the x-axis, right? Because that's where it crosses the x-axis, the x-intercept. And to find the y-intercept, we plug in a 0 for x, and we want to know what y is, right? So we're going to do 4 times 0 plus 5y equals 20. 4 times 0 is 0, so we just have 5y equals 20. Divide each side by 5, and y is equal to 4. So that means our y-intercept is 0, 4. Okay, and finally graph it. We want to just try to graph it as straight as possible. Oh my goodness. Okay, so there we go. There is our line. And again, you want to make sure you're reading directions here because we could put this into y equals mx plus b format and then graph it using slope and y-intercept, right? But it specifically says to find the x and y-intercept. So again, the x-intercept, you plug in a 0 for y. And to find the y-intercept, you plug in a 0 for x. Next, it says write the slope-intercept form of the equation through the point with the given slope. So we have, we want to go through the point 0, 2, and we know we have a slope of -3. So we're going to use this point slope formula here. Y minus y1 equals m times x minus x1. So remember, our y and our x are always going to stay the same. It's our x1, y1, and m that's going to change. But again, that's going to be given to us. So the slope is given to us, which is m is -3. And then we know x1 and y1 because that's our point that's given. x1 is 0, y1 is 2. So if we just can identify what m, x1, and y1 are, this formula will be given to you and you just plug it right in. So y, like I said before, stays the same, minus y1, which is 2, equals m, which is negative 3, times x, minus x1, which is 0. So here is where we do some simplifying. Remember, sometimes you'll have a double negative here, and you can simplify it to become a positive. Fortunately, we don't have to do that. It just will stay negative. And then here, we do have to distribute. So y minus 2 stays the same. Negative 3 times x is negative 3x. Negative 3 times 0 or negative 0, whatever you want to think, doesn't matter because it's times 0, which will just be 0 anyway. So I don't have to write that in there. But I do want to get y by itself. So now I'm going to solve for y. Y is being subtracted by 2. So the opposite would be to add 2 to both sides. Negative 2 plus 2 cancels, and I'm left with y equals negative 3x plus 2. And that's it. That's our final answer. Y equals negative 3x plus 2 is the formula of the line that goes through the point 0, 2 and also has a slope of negative 3. All right, next we have write the slope-intercept form of the equation of the line given 2 points. Okay, so I should have copied this over. So y minus y1 equals m times x minus x1. We're going to use the same formula. But anyway, when we have to figure it out between 2 points, we first have to find the slope. The slope is not given to us. So we have to do y2 minus y1 over x2 minus x1. So we can go ahead and label our 2 points, x1, y1, x2, y2. And we're just going to plug it into our slope formula because, again, we're trying to find what slope is. So y2, I have 5 minus 3 divided by negative 1 minus 5. So I can simplify. 5 minus 3 gives me 2. Negative 1 minus 5 gives me negative 6, but I can simplify this 2 over 6. I know I'm just going to have that negative in there, and it would become 1 over 3. So that means I have a slope of negative 1/3, and then I'm just going to pick x1 and y1. So x1 we labeled 5, y1 we labeled 3. And again, we're going to plug it into that formula, y minus y1 equals m times x minus x1. So y and x stay the same, so y minus y1 is 3, m is negative 1/3, multiplied by x, and then we're subtracting by x1, which is negative 5, or minus 5. All right, so now from here, if this was a double negative, we would simplify. It's not, so it stays the same. And over here, we're going to distribute. So y minus 3 stays the same. Negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 5. Well, that double negative will change to a positive. And I will get 5/3. Okay. And last but not least, I'm going to add 3 to both sides because I want to get that y by itself. So I get y equals negative 1/3 x. And I have 5/3 plus 3, that's 4 and 2/3. Okay, so this would be our final answer here. So again, when we are trying to find the formula of a line, or writing the equation of the line through 2 points, find the slope first, choose one point as x1, y1, and plug it into our point slope formula. Next, write the equation of the line that passes through the point 1, negative 3, and is parallel to the line y equals 3x minus 1. So remember, if it's parallel, that means they're going to have the same slope. So we're going to use the same formula here. Our point is x1, y1, and the slope is going to be the same. So if we're looking at our line, we have y equals 3x minus 1. Our slope is 3. So when it's parallel, we have a slope that's the same. And then x1, we have 1. Y1, we have negative 3. Again, I'm pulling that from this point here. So from here, I'm going to plug in all this information into my formula. So y stays the same, minus y1 is negative 3, equals m, which is 3, times x minus x1, which is 1. So I'm going to simplify. So here's where I have a double negative, so I can simplify that to be y plus 3. And then I distribute this 3 here. So 3 times x gives me 3x. 3 times negative 1 gives me negative 3. And finally, I want to get y by itself, so I'm going to subtract 3 from both sides here. So 3 minus 3 cancels, and I'm left with y equals 3x minus 6. So here is my final formula. This is a parallel line to y equals 3x minus 1, and it also goes through the point 1, negative 3. Next, we have write the equation of the line that passes through the point 3, 0 and is perpendicular to the line y equals 2x plus 2. So just like the last one, it'll be very similar. The only thing is the line is perpendicular. So that means the slope will be the negative reciprocal. Okay, so the slope of the perpendicular line, since it's a positive 2, will become negative. And the reciprocal means we're going to flip the fraction. So 2 becomes 1 over 2, and it's negative. So we have negative 1/2. And then we have our x1 is 3, and our y1 is 0, and that again comes from this point here. So now we simply plug it into the formula. Y minus y1, y stays the same, minus 0 equals m, which is negative 1/2, times x minus 3. Y minus 0 is just y. And let's distribute. Negative 1/2 times x is negative 1/2 x. Negative times negative becomes positive, and half of 3 is 1/2. So y equals negative 1/2 x plus 1/2 is our final equation of a line that's perpendicular to the y equals 2x plus 2 and also passes through the point 3, 0. Just a reminder, we should all be copying this down on the paper or the Jamboard that I gave you guys. And handing it in by the end of the day will get you an easy 100 as a grade. Okay, next, graph the function y equals the absolute value of x plus 4. So I'm going to go back to Desmos. Desmos is my best friend here. Oh no, I can't see it down here. Okay, so when I type it in, I'm going to have absolute value of x plus 4. And then I'm going to look at my table, and here we go. Here are my points. So I have negative 2, 2, negative 1, 3, 0, 4. I'm going to copy this down. Okay, I do want to see what happens though when x is, because you see right here, these are the points. So when I graph it, it's going to look like it's a straight line. I really want to show that it's that V there. So maybe I'm going to type in negative 6. And remember, you can always add numbers onto this table. So I'm going to type in negative 6, negative 5, negative 4, and negative 3. So now I can see that V in my graph. So I'm going to copy this down right here, negative 6 to negative 3. Negative 6, negative 5, -4, -3, and come back here, and I have 2, 1, 0, 1. Okay, let me zoom in a little bit. Sometimes when you zoom in and you graph, it's a little bit easier to manage. So -6, 2, -5, 1, -4, 0, and then I have 3, -3, 1. So here I can really see that V. Okay, so again, whenever you have this absolute value, your shape should be a V. Next, we are graphing the piecewise function. So remember, a piecewise function is really when you have pieces of different functions. But again, your domain is going to change. So for the first one, we're going to set up our x. In the middle, we're going to have our function. And then we have our y. So for the first function, we just have x. Okay, so that's if x is less than or equal to -1. So actually, I'm not plugging in an x right here. I'm plugging in an x in the middle. That's where the function goes. So I'm going to put a couple numbers that are less than -1. So maybe -3, -2, and -1. And I'm going to use the function x. So when I plug in a -3 to just the function x, I'm just going to get out -3. Same with -2. Same with -1. Okay, but the really important thing here is when x is less than or equal to -1. So that means that this point right here is going to be a closed circle when we graph it. Okay, now I have -x plus 4. Maybe I'll do 3 points for that. So when x is greater than or equal to -1, I'm going to start with a -1. Always start. This number here is going to show up twice in our x values. So I'm going to do -1, 0, and 1. So if I plug in a -1, -1, it really gives me a +1, plus 4 is 5. Then I plug in 0, 0 plus 4 is 4. And then I have -1 plus 4 is 3. But remember this point, when I have greater than or less than, which I have there, that means I'm going to have an open circle. So now I'm going to go to my graph and plot these points. -3, -3, -2, -2, and -1, -1. Now I have to make sure that's a closed circle. Okay. So I want all the points that are less than -1. So less than goes to the left. So I want to make sure I'm going down and kind of pointing to where the x values are getting smaller. And then next, I'm going to graph -1, 5 with an open circle. 0, 4, and 1, 3. Okay, and again, I want the greater, so it's going to go kind of down and towards the right for the bigger numbers. Okay, so again, this is your piecewise function. Okay, state the values of A2, A3, and A of 4. So we know the first number is 3. We have our formula A of n equals 1 plus 2 times A of n minus 1. So A of 1 is 3. That means A of 2 is 1 plus 2 times. Now, if we were to plug in a 2 right here, 2 minus 1 really gives me 1. So it's really saying take A1 and multiply it by that. And really what you're going to find is you're just going to continuously take the number that you get before it and plug it into the next number in your sequence. So 2 times 3 is 6, plus 1 is 7. So when we find A of 3, 1 plus 2 will stay the same. But now we're going to take this 7 here and bring it down here. So 2 times 7 is 14, plus 1 is 15. And last, we'll find A of 4. So we have 1 plus 2 times, again, we're taking this 15, adding it in here. 2 times 15 is 30, plus 1 is 31. So there are our values for A2, A3, and A4. And last, write an equation in slope-intercept form to model each situation. So remember, when we have slope-intercept form, M is what's changing, B is where you're starting. Okay, so it says you rent a bicycle for $20. That's where you're starting. You must pay $20. Then it's changing because you're adding on $2 per hour. So we have y equals, we're going to take that 2, that's what's changing, x plus 20. So that's it, y equals 2x plus 20. And next, a candle is 6 inches tall and burns at a rate of ½ inch per hour. So now this one, if you think of it, when a candle burns, the candle is getting shorter. Okay, so you're taking away some of the length of the candle. So you're going to have y equals, since you're taking away this ½ an inch, it's going to be -1/2 x plus 6. Again, the candle starts at 6 inches, and each hour it goes down ½ an inch. And that is the end. That was, believe it or not, all of the topics that are going to be on the test tomorrow. So there's probably not going to be this many questions, but I just wanted to make sure we went over everything so that you are prepared for any type of question that's thrown your way. So again, you should have this all copied down and handed in for a classwork, an easy classwork grade of a 100. Okay, I did it this way because I wanted you to copy it down so that you can really study for your test tomorrow, because I hope that we all do well on it. So if you have any questions, please let me know, and I will see you guys tomorrow.